And get on our way. Hello, everyone. Welcome to Intro to Spring Boot, kind of an overview-y sort of thing. I want to talk a little bit about what an HTTP framework is sort of all about, and then I'm going to walk through all of the steps in that guide. Do not follow along with it. It's recorded. You can watch the video, but we're going to go kind of quick so you can see how all the steps fit together. This is one of those. All right, so let's talk about why we need such a thing as a framework for this. So the fundamental problem we're trying to solve in back-end engineering is data persistence and delivery. So if an HTTP request comes in to the black box, how do we get an HTTP response back that has our stuff? So this black box, that's the back end. There's a couple pieces to this. The thing that's actually running on the server and listening for these HTTP requests on like port 8080 or whatever, that's this really thin layer here called Tomcat. Alternatives to that, Node has one that's just sort of built in. Python has Simple Server. There are other, Apache, Nginx, which you've seen before, but you might not know that it's pronounced that way. All of those are server software. Their job is to listen for HTTP requests and then call programs on the computer, like when certain requests match. So in our case, Spring Boot has Tomcat embedded inside of it, so it handles all of that part of it for us. So this is going to take that HTTP request, and it's going to send it into our Spring Boot app. This whole box is the server. Spring Boot app is going to go into the entry point, and then it's going to route, all right, what was the path on this? What was the method? Where am I sending this? And so based on that, it figures out a controller to send it to. Controller is what handles the logic of how any particular request is handled. The controller is going to ask for data, or send data, either way, to a service. This works exactly the way that it did in Angular. It's not even different. That all of our data is like abstracted out into these services that we use. Service is going to request data from the database via a repository. Repository's job is to actually generate the SQL requests. To the database. Database comes back, sends that like raw data over to the repo. The repo goes, oh, I need to turn this raw data into Java objects. So it makes instances of classes that are called models. Sends those back to the service, which sends those back to the controller, which ends up going back to the entry point, which goes over here, which becomes the response. HTTP request comes in, server catches it, sends it over to Spring Boot. Spring Boot sends it to a controller and goes, hey, what do I do with this data? Controller's job is to figure that out. It's going to call a service, which is all of our data abstractions. Service interacts with the database through a repository. Repository makes the request, gets the data back, and then hydrates that data into like actual Java objects. We send those back to the service. Maybe we format them. Maybe we do something with the response. And the controller goes, all right, all good? And we go, all good. And it fires it all back as an HTTP response. Meanwhile, the thing that made the response we had this Angular app over here where like the router fired up a route, which was a component, which used a service, which generated that HTTP request. And when this response comes back, it comes back to that service, it's bound to that component, and stuff shows up. It's a preview of our full stack chat. But that's how all this fits together. All these pieces are called software architecture, by the way. High level, that's what Spring Boot is doing. Questions?
Is the repository basically a container that holds those SQL commands we were learning?
Sorta. It's a container that holds instances of the data. It actually is also kind of responsible for whether or not it generates a new query or just gives you back the results from the last time it ran that same query. That's why it's called a repository. And it knows how to generate a SQL query based on data that you give it. So you might say, hey, give me all of the dogs. And it goes, all right, the way that I get all of something is select all. And you said this was a dog, is that right? Well, I can look over on the model and see that the table that's attached to that is called DOG. So I'm going to select star from DOG. And then like that's the query that it generates. But all the logic for how that happens, that's part of the repository.
Okay.
What else? All right. High level, that's what's happening. We're going to refer back to this. Now, let's head over to the Spring Boot guide. You got yourself some wood veneer. Okay, so step one, I got to scaffold out the app. So this app is going to be shit, let's just do the Barkwire one. I have a good idea for the full stack one. I think you'll like it. All right, so if I run this, come on, not that. There we go. All right, so let's break this long initialization thing down a little bit. I'm making a new Spring Boot app. The version of Java I'm using is 11 because that's the version that I have installed. The group that I'm going to use, this is my reverse domain thing. So I want that to be Sika Education. I need to give the app a name. So I'm going to call it Backwire, the dating app for dogs. All of these dependencies, those are fine as is. Oops, come on. And then I want to put this all in a folder called Barkwire lesson. Cool. So if I head over to my Barkwire lesson, that's my Spring Boot app. So that's what that scaffolded out for me. Couple things to note on this. The POM XML, this serves the same purpose as a package.json file. This is all the dependencies for the app. MVNW, that's like NPM. Like running that, that'll have all of our like start commands and our test commands and like that kind of thing. And then the source folder is split into these two main branches that kind of mirror each other. So the main, that's the actual app code. The test is, spoiler alert, the test code for this. Main is also split up into your Java source code and then like your application configuration stuff. So any configuration stuff you need to do with, like, for example, all those dependencies you installed, that all goes in that file. Otherwise, this Barkwire lesson folder, that's like our project folder. So the next thing we're supposed to do is initialize our project as a Git repo with git init. It actually already has like a pretty decent git ignore file. It just doesn't initialize Git for us. So we're going to use environment files in this, so we also want to run that command to add that to our git ignore. All right, create DB, time to make a database. So I'm going to create DB Barkwire lesson. Done. All right, and then I need to make this env file. The purpose of env files is that when I'm developing an application, I've got my Angular server, and I've got my Spring Boot server, and I've got my database, and I've got my browser. And I'm pointing to like all these things that are on my computer. That is your dev environment. If I want anybody who's not on my computer to be able to access this stuff, I need a database server. I need a static server like Netlify. I need an app server like Heroku. And so then my browser needs to be able to, instead of going to this Angular server here, needs to ask for that stuff from there. It needs to ask for, so let me make that blue. Needs to ask for that from there. It needs to ask for data from this app server, which is getting it from there instead of from there. So all of this code, these things all point to different places in the production environment. It's not different code. The logic is identical. It's only things like literally what URL do I go to? It's like a localhost one in development, and it's like a Heroku one in production. So I just need some place to keep track of those different environments. That's what an env file is for. So I am going to touch.env. I'm going to open it up. So I'm currently setting up an environment for development. And so this is going to be like Barkwire lesson. Everything else is the same. Fine, fine. All right, and so then I need to add spring.env. That's what's going to allow this to read this file whenever I run the app. So I add this dependency to my POM XML. This is just like npm installing something. So find this like big list of dependencies here and anywhere in here. Like that. Done. Over in application properties, if you'll remember, that was our like configuration for the app. All of this is the compiled stuff. So it's like target is the opposite of source. All right, so I'm going to open up that application properties file. Oops, that wasn't the target. There we go. I'm going to add these in. So these use that .env dependency that we just installed. And it's going to read these values out of that .env file instead of hard coding them. So this is my actual like application configuration code. And so then I can use this .env file when I'm on my computer. And when I push this up to Heroku, I can put different values for Spring Data Source URL and Spring Data Source username and all that stuff on Heroku. All right. Then I need to make a file called system.properties. This is a GitHub thing. It needs to know which version of Java that I'm using because it uses 8 by default, which is a little bit older. So I need to set that to 11. All right, time to launch the app. So if I do .maven w spring boot run, oops, I need to be in the folder. Oops, come on, Daddy. It's not Maven, it's MVN because we're in Java land, and of course they do that stuff. But that's the name of that file. So it's compiling all these Java files. And when it's done, what we'll see at the bottom is Tomcat started on port 8080. And so if I go over to localhost 8080, cool. That like this came from Spring Boot. It looks like an error, but that means that I haven't done anything with this app. There are no controllers, there are no routes, there's nothing. But it means that, so I 404'd, which is good because I didn't make anything. But that means that's working. All right, so next thing I want to handle those 404s a little bit better than that. So I'm going to create an exception directory, or one might say an exception package in the app directory. So the app directory, if you'll remember, was in source, main, Java, com, seek education, Barkwire lesson. Hey, there we go. This is our app directory. So that was 404 handler. Make an exception directory. Done. And then add a file in that directory called resource not found exception.java. Now, when I open that up, got this empty file. It's going to want us to declare what package it's in and then do all of that stuff. So if I copy and paste this stuff over. All right, what package was it in? I mean, the error will just tell me. I was expecting com.sikaeducation.barkwirelesson.exception. Well, I can do that. So much the better if it does most of it for me. Cool, so what this says is the resource not found runtime exception will just respond with HTTP status not found. That's all it does. All right. Adding a resource. So all of this is like just general app setup stuff that we've done. Our app still doesn't do anything. It's just configured and like can run without exploding. So in this like application code directory, we're gonna want to make a resource. So if this is Barkwire. Actually, before I start doing the resources, questions?
So with what we installed on Visual Studio, is there any reason we shouldn't be doing that, like start a Java project and just go through those steps? That kind of does it automatically?
No, you should follow this guide.
Okay, just checking.
Use the Spring Boot CLI. It's what everybody uses for initializing Spring apps, Spring Boot apps.
Was that app configuration written in JavaScript?
No.
Okay, cool.
Talking about this?
Yes, sir.
No. That is, man, what is that?
Almost JavaScript.
Not really. So what they're trying to do is a hierarchy. This is like a condensed way to do YAML. So the other syntax for that some people prefer, but I don't think it's actually set up by default. Maybe you can just change the extension and it works. So the other way you would write this is nested as YAML. And then these are already in Spring Data Source. These are already in Spring Data Source. This is already in Spring Data Source. And then this is in Spring, but it's under JPA and Hibernate. Like that. That and this are the same thing. This is just a condensed way to do it.
So not JS at all.
Not JS at all.
Very cool,
like,
thank you.
But things like these things that sort of look like template literals, like JS got them from somewhere. That's like a pretty common thing for templates. It's not universal, but it is common. Good question. Other ones so far?
Not a question, but I guess I'm just surprised there isn't like a macro, to do all of this for you.
You already used the macro. The macro was making all of those folders and wiring all that stuff up. Java developers think that this is no work at all, and they're like, come on, baby, do you need me to cut up your hot dogs for you too? I think a lot of Java devs are like appalled by how little work this is. I don't know why that's a thing. Like, but how much something like Angular CLI has all of this stuff just baked in, I think that makes a lot more sense to do it that way. And I'm very surprised that for something as like 20 years old as Spring, that there's no way that you can, there's no Spring Boot CLI command for like generating all of this stuff. And their rationale on it is, oh, well, people like organizing this stuff in different ways. To which I would reply, what a useless source of variation. Because like they probably shouldn't be. But yeah, this is like the opinionated, not opinionated continuum.
That's interesting. Thanks. And for what it's worth, hot dogs do taste better cut up.
Especially when somebody else does it for you. That's so my children say.
Only one mix of mac and cheese.
There you go. Other questions?
Like a pretzel sticks kind of guy, Matt, but yeah, that works too.
Fucking melting down. Other questions about application setup? All right, let's make a resource. So over here in the backwhile lesson folder, I'm going to make a new package called dog, singular. And we go into dog, and I'm going to make these 4 files. I'm going to make a dog.java. I'm going to make a dog controller.java. I'm going to make a dog service.java. I'm going to make a dog repository.java. Like every resource doesn't necessarily have all 4 of them, but I would guess like 80% of them probably do. So this is a pretty common pattern. So let's hop into the model. Where am I? There we go. So the stuff that goes in a model is like so. All right, so first thing we need to fix the package, and hey, it tells us exactly what it should be. com.sikaeducation.backwhilelesson.dog. All 4 of these files are going to be in the same package, by the way. All of these, it's also barking at us here, pun intended, that hey, if this thing's called some resource, well, the file's called dog, so shouldn't this be called dog? It's mad about that too. So now all's right with the world. These imports, like if you didn't have them, that's what you'd rely on your text editor or your IDE to do for you. So like if I get rid of those, it's going to go, hey, what's an entity? And then I wait for my editor plugins to catch up. There we go. Import entity. Do I want to do it from here or here? Well, I want to do it from Hibernate. Or nope. Maybe from JavaX. Yeah, there we go. Data. There's probably more than one of them, but I want the one from Lombok. Table. Where's that come from? Probably the same place as entity does. What's an ID? Probably from the same place. What's a generated value? Probably that. Probably that. Probably that. And then they're back. So like using your text editor to resolve all those imports for you, that's like bread and butter Java work. All right, so what this says, entity means, hey, this is a model. Data means generate all my getters and setters for me. So whatever you have as private properties, it will generate a get ID method and a set ID method and a get name method and a set name method automatically. It's pretty cool. And this is, hey, whenever this model gets tied to a database, what table would you say it goes with? So we can say it maps to the dog table. This is how we handle auto-generated IDs. Mark that it's an ID. Mark its generated value type. The IDs are traditionally longs, FYI. That's a pretty good default for that. And then these can be whatever. So I could also have one for like breed. Its name is breed. Cool, that's models. Repositories are even easier. We hop over to that repository file. So like I declared the package or imported the model on here, but they're in the same package, so it doesn't matter. If I do, let's see if it'll auto-complete it for me. Yep, there we go. So if I declare the package, again, exactly the same as the one I used for the model. And I annotate this as a repository. I'm going to call it dog repository. And then some resource, I need to say what goes in the repository and how they're identified. So that's the type of thing that I'm storing in here. That's the type of the ID that you use for those. And that's it. Repository is done. Note that it's not a class. It's actually just an interface. But this will add a bunch of methods that our service can use. All right, so over in our service. Anything that we want to be able to do with the data goes in here. So if I go over to dog service, copy and paste that in. Hey, that's not the package. Fixed. So we mark this as a service. It should be called dog service. The repository that it uses is a dog repository, and we can just call it dog repository. This auto-wired thing, that's same thing as dependency injection. So like when we use a constructor in Angular, and oh, well the type automatically lets us inject that dependency in. This is that same thing in Java. Is, hey, can you make a property on here called dog repository? And by saying that it's of type dog repository, it just links it up with this interface that we just made. And then all of these are our CRUD actions. That's going to be listing. That's reading. That's creating. That's updating. That's deleting. So if we want to list something, it's going to be an iterable of dogs, which we can find from the dog repository. This is a good example of what repository methods look like. That's going to end up generating select either all or more realistically probably name, breed, and ID from dog. But instead of writing all that out, the repository abstracts it all away just behind this find all method that we get for free. Done. Getting a single one works the same way. We wrap it in an optional, which is built into Java. That's effectively saying this might be null, which comes in handy for all the same reasons that checking that stuff in TypeScript was helpful. So we don't accidentally call a method on something that might not exist. So creating, well, that creates a dog. It takes in a dog. And then with the dog repository, saves it. Cool. This is the most complicated one. Also, I think that this is the thing that this Hibernate ORM that we're using that has all these methods, I think it's the thing it sucks the most at. This is the one I was like, really, you guys have not found a better way to do this. Okay, well, your framework. But it's going to be found dog. So you're going to look in the dog repository for whatever dog you were given's ID. And is present is what you do with an optional. So if there was a found dog, then I want to calling get with no arguments like unwraps the optional. And so now I just have like an actual dog model. So we're going to call that updated dog. It doesn't have anything in it yet, but that's what it will be. So I can update those two. And I want to set the name, and I want to set the breed. So some resource, that was our dog that was passed in originally. I'm going to get its name. I'm going to get the breed. These came in from the HTTP request. So when you send an HTTP request that has dog data, this is you saying the name and the breed of the dog that I just passed in, set those to the name and the breed of this dog that I found in the database, and then save that dog. That'll write the query that updates that in the database. Doing every one of these properties by hand, I think is whack. Like, most other ORMs handle that a lot better. But yeah, as far as I can tell in Hibernate, it's a pretty manual process. And then deleting, that's pretty easy. It doesn't return anything. It takes in an ID to delete and deletes it. And that is services. So last piece of the puzzle is this controller. So what we've done, so that the controller's right here. We made a model. We had a repository that connects to the database there. We just did the service that talks to the repository. Now we need the controller that's going to use the service. So if I go over to the dog controller, this one's got kind of a lot happening in it. But anything relating to that actual HTTP request, this is where it goes. All of the dog service stuff was just about anything that might want to interact with dogs. These are specifically those HTTP requests that we want to handle with our API. So we fixed the package. This is still the service. Oh, it's because I didn't copy the right thing. Hang on. My computer's getting tired. Seriously, man? Come on. like it can't keep all of it in memory long enough. Let's try one more time. Yeah, it shits out before it gets there. All right, so change of plans. We'll do it in a couple steps, apparently. So first I'm going to take in all these imports. Then start at the request mapping. Get this stuff. All right, auto format it and start cleaning it up. So first thing, it's in the same package.
I have a question.
Yeah, hit me.
Sorry. So I know like we have this excellent guide to follow,
Yeah.
but normally would a developer just know this by hand, or do they copy and paste from somewhere too?
They probably copy and paste it too.
Okay.
I guess it depends on how long they've been doing it, but somebody who's like a newer Spring Boot developer, I would guess that they're using a reference for a while.
Okay. Thank you.
Bark wireless and dog. Did I? I don't think I did. It's mad about something. So I need to import my exception. This is the thing that's going to throw the exception. So it'll be com.seekaeducation. Bark wire lesson. But otherwise, it's going to be on exception. So why is it so upset? Something got, oh, that's why. Oop. All right, that's better. So when we start actually writing the controller, cross origin is an annotation that's going to let us call this from an API. Otherwise, you can't make a scripted request. This is what identifies it as a controller. And this is where we start mapping the URL. So this would be like dogs. And so if I go to localhost 8080/API/dogs, everything else inside of this will be relative to that. So like to get a particular dog, it would be API/dog/34, some dog ID. And so when we actually see that one, that just gets added to the end of the request mapping. I got to give it same name as the file. This is me injecting the service the same way I injected the repository into the service. I got to inject the service into the controller. So this will be dog service. Dog service. Cool. So then if I make a GET request to just API/dogs, it should respond with a 200 status, and it should return a map. That's a hash map that has string keys and an iterable dog as values. So I'm going to say this is an iterable dog. These are dogs. And this is going to be from the dog service. I'm going to call that dog service list method. And then I just made this create hash plural thing there. It's a little like helper method. But that list method, I defined that there. that create hash plural, that's down here. I just need to fix the types. Cool. Now, hey, that thing's not mad at me anymore. We're gonna make it after all. If I make that a dog, I make that a dog, I make that a dog, and I say, hey, take that dog service, find and try to find by the ID that I read out of the path. That's how we do like dynamic segments in this. And then we put them into the method with this path variable annotation. Find me a particular dog, and if you can't, throw my 404. Otherwise, make me a singular hash. So that was another little helper that I made down here.
I have another question. Sorry.
Yeah, hit me.
Is an irritable like a collection, a collection?
No, it's not. You can turn it into a collection, but it is not actually a collection.
Okay. So then, what is it?
Like we don't need to iterate with it at all. We're just returning it,
Okay.
and so it's not a big
Okay.
deal. There, like if you look up Java convert iterable to list, or like array list. Any of these will get the job done. I think Bale Dung has like a bunch. There we go. There's a whole bunch of different ways you could do it.
Okay.
But yeah, that's probably the easiest. Is make your new like array list, and then take whatever your iterable is, and then call its for each method, which is a stream method, I think. And then this double colons thing, this means call this method from this class on like each of these things. And then all of a sudden your list has all the things in the iterable. But yeah, you kind of got to do it by hand.
Okay. Thank you.
You're very welcome. Good question. All right, if I want to make a dog, swap all those out. Dog service dot create with some dog. Was it create? Yep, there it is. And then our created resource, that's like a created dog. Done. If I want to update something, I can say, hey, this is going to be given a dog as part of the request body. This is how you pull data out of a request body, is with that annotation. Updating. But yeah, same thing that we did up here with request body. Validated is kind of a cool annotation too. If you send data in the wrong format, like it doesn't have the right properties for a dog, it'll just automatically generate an error. Kind of nice. It's going to be an updated dog. This is going to be some dog service. This will be dog. Change those errors to be a little bit more helpful too. Ooh, not some dog service. Just dog. We just say dog service, buddy. And then take our updated dog and serialize it. Last one. So if I take the dog service and delete by ID, whatever that ID was. That's it. And then these were my two helpers. And all these helpers do, make a new hash map and set dog equal to dog, or dogs equal to dogs. Like so. Cool. Well, now what? Deployment already? And we're already at the additional resources? GTFO. So if I head over to Heroku, first thing I'm supposed to do is make a new Heroku app. Oh, good gravy. This is always such a pain in the ass. Heroku got hacked is not the PC term anymore. They had a compromise, and so they've been a little bit obnoxious on security lately. So Heroku serves the same purpose as Netlify, but Netlify is static hosting. This is app hosting. So we're renting a little computer from them. They're not just holding files for us. So we're going to call this Barkwire lesson. And let's see. Add a Heroku Postgres add-on to it. That's the database. So I can go over to Overview, Configure Add-ons, quickly add add-ons. How about Heroku Postgres? And then it says, hey, do you want to pay for this? Why, no, I don't. Cool, done. Connect it to a GitHub repo. Oops. All right, so if I commit all that, head over to GitHub. This was breaking for me the other day, so we'll see. I'll get to show you the workaround if it doesn't. All right, so I'm going to add this remote origin. I'm going to push it up. And, all right, apps live. So if I go over here and go to deploy, connect to GitHub, connect to GitHub. Barkwire lesson. Cool. Do I want to enable automatic deploys? You know I do. I don't like doing that work. Okay, cool. So if I want to watch my deploy happen, I can head over to the logs. Oh, I might need to manually push a change. If I do... but I make a README for it. Oops. Oh, still need to. It's an untracked file. There we go. All right, so when I deploy that, watch what happens. Heroku's going to pick up on that push one of these days. Ten seconds is a lot longer than you think. Let's see if it failed. Oh, well, should have told me. Is that where I pushed it? Get remote dash v barkwire lesson. Barkwire lesson. Automatically deploys from master. Good. Oh, I could manual deploy it. I don't think I'd need to, though. Hey, there we go. So it is up now. All right. Well, what happens if I go to, what's the name of this app? There we go. So if I go over here, hey, it's the same white label error page, but if I go to /API/dogs, ooh, that looks sort of kind of like one of those APIs I've been hearing so much about. And if I fire up Insomnia, I might even be able to make one of those dogs. All right, so this was barkwire lesson.heroku app, I think. And it's going to be a post request. Shh, there we go. All right, so I'm going to send a post request to this URL. By the way, that's not like on my computer or something. That's on the public internet. And I'm going to send this data over. Let's see what I get back. Hey, cool, it added a dog. Can you give me another one? Mesa was a Jack Rascal Terrier. 201 created. And Harmony is a piggy. Okay, cool. Looks like I've added 3 dogs to that. If I hit that API endpoint, hey, weird, this kind of looks like the stuff that I got back from the Pokemon API. I wonder if I could interact with it in exactly the same way with my Angular apps. Well, yes, I can. Even this like post request, could I do those with like a form in Angular? Why, yes, I could. And that is a full stack application.
Can anybody add dogs to this?
Anybody can add dogs to this.
In your Insomnia software, can you add another field for like an image URL and then it also be added to the API?
Nope, because that is just for interacting with the interface that this server defined. The server didn't define an interface for adding fields to a model, nor should they. So how I would do that is I would change my model to also take an image URL field.
Cool.
And the way that I would keep anybody from being able to add a dog to my API is with authentication, which is out of scope for the course. We did a lot of other, we did problem solving instead of like auth for 3 weeks. You're welcome. More questions about this?
Do you since we did the whole thing, you recording this, do you recommend us just running this straight through on our own?
100%.
Okay.
Like,
awesome.
and this is one of these things where the chances that any of you are going to really get controllers and repositories and models and Spring Boot architecture and all this in 3 weeks, like, no way. Absolutely not. This is something you're going to have to crank with for a while. It's probably a little more complicated than Angular was. But the good news is that Angular apps, those can be anything. Like, every app you've ever used in your life is different. Most APIs tend to be kind of the same. So the stuff that we did for this model, I'll bet that's not so very different from a lot of the stuff that you end up doing on the job. Like, now where like the back-end engineering work really comes in is, let's say the thing that would come back from find all in the repository, let's say that's 2 million records. Well, that doesn't work. So how do we get just enough records? So we might need to tune that a little bit. Or authentication is like another big one. Who is allowed to do what under which circumstances? How do we test these? How do we test the performance of these to make sure that they're fast enough? Because if it takes 3 seconds to process one of these requests, that's a bottleneck in this HTTP request cycle. That's 3 seconds from when you click the button and get your response back. And that's before you add any of the weight of, I don't know, going across the world with this HTTP request and back, and all of the like performance considerations with your app on the client. And so like this stuff tends to be a bottleneck. And so you want to try to find ways to make it as quick as possible. So all of that stuff ends up being like major concerns in back-end engineering. But the overall structure of like, I store some stuff and then I make that resource available through a REST API, like by design, that stuff is supposed to be kind of repetitive. So what I hope you'll be able to do by the end of next week is reliably do all the things that I just did. And I'd like you to be able to describe like what controllers, services, repos, and models are. If you can do that, that's pretty good shape for Spring Boot. If you can get that relatively quickly, this is not a requirement for your capstone, but I have a hunch that many of you would be able to make cooler things if you could do this. Have models that relate to each other. So like one owner has many dogs. And so you can go, hey, can you give me all of Kyle's dogs? That's like an extra step on top of all this. If we don't get there, I'm not going to lose sleep over that. If you can follow the instructions and copy and paste and modify code and stuff for all the stuff that I just did, that's not a bad place to be next Friday. Hit me with some questions.
So the information that gets pushed into the API, where is that stored again?
So when you send that data over in the body of an HTTP request, Tomcat goes, oh, here's the controller for that. The controller goes, oh, you're trying to add data? That's the create method. And then the create method goes, I'm going to use the create method of the service. And then the service goes, I'm going to use the create method of the repo. And then the repo generates the insert into SQL query, adds it into the database, takes the thing that it gets back, modelifies it, gives it back to the service, gives it back to the controller, gives it back to Tomcat, it comes back to you with the ID that got added from the database. But think about that like statelessness kind of thing. as soon as you navigate away from your client, it's all wiped. Like none of that stuff is there anymore. Anything that you want to keep was either in local storage or it's gone forever. Server's the same way. If I'm like storing stuff in variables on the server, watch me play God. Restart all dynos. Well, cool. All of those are gone now. It restarted the app, so it reinitialized everything. All that stuff is gone. The stuff that I want to keep, like the dogs that I added, that stays in the database because that's what databases are for. This is data at rest. Everything else is data in motion. So even though I restarted that app, I still got my buds.
Is there any way you can show like where in the code, like how does it know to keep that stuff, or is it just does it natively?
So if I grab this database URL, this was like auto-generated by Heroku when I added that thing. P-SQL. Hey, what tables are in here? Oh, there's a dog table. Can I select all from dog?
Okay. All right. I see. Thank you.
And then the way that Spring Boot knows where that is we told it what table like maps to this class, and then we told it what each of the column names were. More questions?
At some point, if we do have time, would you be able to show us how we could get that multiple model thing going on?
Not today.
Not today. Yeah.
Next week.
Cool. Thank you.
What? This wasn't hard enough? Any more questions for lunch?
Not
It was
that I
plenty
can
hard
properly
enough.
articulate.
All right.
Very confusing. We'll get there.
So that's like what I was hoping for is that this can be a guide for you, like to supplement the written guide as you're going through this. A lot of this is just going to be like copying, repetition. That's okay. You don't need to understand every part of this. It's going to make a lot more sense if you can get APIs up and running, and you're going to break them just naturally, just from not like copy pasting correctly, from experimenting with something and the experiment kind of goes wrong. You'll learn a lot from that too, and trying to fix that and rewire the pieces back together. But this is a pretty good place to start. Okay, cool. Hopefully that's helpful. Have a good lunch. When we get back, we're going to see how everything fits together end to end. Cheers.